Between 2023 and 2024, the AI race was largely defined by a simple assumption: the best model wins. By 2025 to 2026, that assumption no longer holds. Today, leading companies such as OpenAI, Anthropic, Google, and Meta are no longer competing solely at the model layer. Instead, competition has expanded across the entire AI stack. Model architecture, training and alignment pipelines, inference optimization, tooling and agent frameworks, distribution channels, infrastructure, and compute. This shift leads to a critical conclusion. Large language models are no longer products, they are components within larger systems. OpenAI follows a product-first strategy where usability and integration are core priorities. Multimodal models designed for instruction following, tool interaction, and agent-based workflows. Training strategy, heavy reliance on post-training, RLHF, instruction tuning, emphasis on practical alignment rather than theoretical purity. Inference layer, optimized for low latency and real-time applications, strong support for structured outputs and function calling. Industry-leading tool use and orchestration. Smooth transition from text generation to action execution. Strong API ecosystem integration, not always leading in deep reasoning benchmarks, heavy dependence on post-training techniques. OpenAI is not necessarily building the most intelligent model, but the most deployable and usable system. This distinction is strategically significant. Anthropic takes a reasoning-first approach, focusing on model correctness and stability. Constitutional AI, rule-based alignment framework instead of purely human feedback. Training focus, chain of thought consistency, and logical reasoning robustness. Strong long context handling, high stability in multi-step reasoning, excellent performance in coding and analytical tasks, less emphasis on tool integration and agent ecosystems, weaker product layer differentiation. If the model reasons correctly, the surrounding system becomes simpler. This approach may provide long-term advantages as reasoning becomes a key differentiator. Google approaches AI as an infrastructure and scale problem. Full stack control via TPU-based training, massive datasets from Search, YouTube, and Gmail, deep integration into existing ecosystem, retrieval native AI, search, productivity tools, Workspace, mobile platforms, Android, best-in-class distributed training and inference, strong hybrid systems combining retrieval and generation, advanced multimodal capabilities, especially in video and audio, slower iteration cycles compared to startups. Product experience can lag behind competitors. Google is not optimizing for model benchmarks alone, but for control over compute, data, and distribution layers. This positions them uniquely for long-term dominance. Meta is the only major player pursuing a fully open-weight strategy. Open model releases, for example, Llama family, optimization for fine-tuning, self-hosting, and edge deployment, high flexibility and adaptability, strong support for domain-specific customization, suitable for privacy-sensitive and on-premise use cases, not leading in frontier model performance, lacks a tightly integrated product ecosystem. Meta's strategy is to become the foundational layer upon which others build. If successful, they can win through adoption rather than raw capability. Modern AI systems consist of retrieval, RAG pipelines, memory layers, tool execution frameworks, planning and orchestration. Model quality alone is no longer sufficient. The paradigm is shifting from single prompt to single response to planner, executor, tool chain, feedback loop. In this architecture, LLMs function as reasoning engines, not end-user interfaces. Frontier models are expensive and slow. Emerging patterns include model distillation, small model routing, and hybrid inference pipelines. Well-designed systems can reduce cost by an order of magnitude.